Thanks very much, Sean, and welcome to everybody tonight. Great to have you all here. So welcome to everybody on behalf of Engineers Ireland, and maybe a special welcome to those who are not members, not involved in Engineers Ireland. I want to thank Confirm, the Smart Manufacturing Ireland, with whom we are jointly hosting the event today. Connor is here, was speaking shortly. So Engineers Ireland, well, we're, as many of you know, organised in regions and in technical divisions, about 30 in all, and 3 have come together tonight for this event. So I do want to thank the Thomond region in the Limerick-Clare Tipperary area, and the mechanical and manufacturing division, and also the electrical and electronics division, who have come together, as I say. We've run a number of events over the last couple of years on Industry 4.0 and digitization in general, and that they've all been very good, as I've no doubt tonight will be as well. And it's a really important area for us in Engineers Ireland, and there will be more and more activity happening, and we'll be linking up to expert bodies like Confirm, who can bring special expertise to the discussion as well beyond our own membership. So I'm sure there's a lot of audience members here tonight who are really experts in this area and at the very forefront of applying digital technology in their businesses. And we'll be looking forward to great questions to really put our speakers under pressure. But as president of Engineers Ireland, I'm really keen to have people like myself here tonight who are learning, who are here to educate ourselves about this and the application of digital technology and industry 4.0 concepts to our own businesses. So myself, for example, I've had a smattering of interface with these concepts. Industry 3.0, I didn't know it was called that at the time, but in retrospect it was, and Industry 4.0 over the years. But I do worry, like lots of engineers worry, that I'm falling behind, that there's a risk I could fall behind the technology. So I look to Engineers Ireland to help me keep up to date with the Engineers Journal and with seminars like tonight. So to me, any of you in this category are really our core audience. Just in terms of my own interface, just a couple of points. Way back in 1985, I was working here in the Thomond region in Ennis in a company called Inland, and was centrally involved in developing one of the very early brushless DC servo motors. It was a big thing at the time. We patented the design, and it was a huge success in the emerging industrial robot market. I mean, we're talking back in the 80s here. So just aware of the speakers tonight who are talking robots and cobots with a huge expertise. Just show a bit of respect. Where some of us old timers were involved as well. So you might be able to talk about twinning robots in the cloud, and I barely know what you're talking about. But if that robot breaks down, I might be very useful to have in the audience, in the sense that I know how the servo drive works and I might be able to fix it. 15 years later, then I suppose I had another contact with this technology in about 2000 when working in manufacturing, and got a lot of recognition from Engineers Ireland at the time for a software system we developed. But we were working in a printing company and linking in 3 plants in Ireland, England, and Germany. We had what by today's standards was very primitive, very rickety database system, but we developed a system where we automatically uploaded every night. It seemed very high tech at the time. The data on our orders and our stocks of materials, and at 3 a.m. every night, the information went up on an FTP server. And at 5 a.m. we downloaded information from the other plants, and it was all there ready for the first production shift in the morning. So it might be very crude by today's standards. We didn't have cloud computing, but I'm claiming this as a major contribution to Industry 3.0. Another 15 years later, again, 2015 now, I was head of the NSAI National Standards in Ireland, a very active in international standardization in Europe and in ISO, at the time when DIN and VDE in Germany really started advocating strongly for standards to support Industry 4.0. And it was an absolutely amazing time and very exciting time to get a sense of the vision that some people have for where this could lead. And I think we'll all get a concept for that tonight when we hear the different talks. So, I mean, I could add to the story by mentioning the work we're doing at the moment in my day job in the Office of Public Works, the OPW, where we're very involved in BIM, building information management, which is transforming how the construction industry works, and historical BIM, which is involved in how you model old buildings and monuments. But really, the point I'm making is only the generic point that, like very many people in the audience, I've had a frequent or occasional interaction with Industry 4.0 and with some of the concepts we're talking about tonight, and many people in the audience are the same. So it's our job and our role, I see it very much the responsibility of Engineers Ireland and other organizations to help the 25,000 members we have in the organization to stay on top of these opportunities and these developments. But anyway, that's enough, probably more than enough from me in introducing it. We have 3 great case studies tonight from education and from industry, and I think it will really get everybody thinking about the topics and push us all. So please ask any questions that you might have through the chat line. It'll be open all the time, but please don't call my bluff. I was only joking about being able to fix the robots. That's a long time ago. If I can manage to keep the microphone off mute, I'm doing well these days. So anyway, thank you everybody for coming along tonight, for attending the seminar. I'm really looking forward to it, and I hope everybody enjoys the event. I'll hand back to you.
Thanks so much, Maurice. Thanks for that introduction. So next up, I'd like to welcome Professor Conor McCarthy, who's the director of the Confirm Centre, to give a few words about Confirm and about the Seedings event also. So Conor, I'll hand over to you, please.
So thank you, Sean, very much for the introduction. And ladies and gentlemen, and boys and girls, I do believe we have some young people on the line this evening. So you're very welcome to this event, which is co-hosted by Engineers Ireland and Confirm. And thank you, President of Engineers Ireland, Maurice, a lovely introduction there, the whole background, and give some context for where we are. I'm just going to use this very brief opportunity to welcome you all to our new headquarters at the University of Limerick. So Confirm is the Smart Manufacturing Research Centre, and I'll just page down here. Basically, I won't go through all the stats here, but it's basically set up in 2017 by a €25 million grant from Science Foundation Ireland. From that, we have to leverage another 50 million between industry projects and non-exchequer funding through Horizon Europe and Horizon 2020 and so on. We're a distributed centre. We're a national centre with 9 academic research performing organisations, and on top of that then we have 26 projects with industry, to a total of about €13 million portfolio with industry. And the University of Limerick have invested recently finished our new headquarters, a €3.1 million investment in state-of-the-art digital manufacturing facility at the gates of Limerick City and beside you just there at the Groody roundabout. Just very quickly to talk through, and we can send this to you tomorrow in the email. We've just launched our global distinctiveness, very important because we're a digital manufacturing research centre that we compete at a global level, and we want to be globally excellent and globally leading in time. And so we have to identify our global distinctiveness, which talks through some of the things that we're really, we think we're really sort of on our way to being more leading in. And the first thing, and Maurice sort of alluded to this a few minutes ago, around Industry 4, what it is, you know, many different definitions, but we think about it around what we call key enabling technologies. So here on the spider diagram, you can see a number of key enabling technologies that we believe we're strong in. We're not strong in them all, and we're very strong in some and less strong in others, but we have activity in all the key enabling technologies that are in Industry 4, from robotics and control to sensors and wireless sensor networks to artificial intelligence, data analytics, predictive modeling, and so on. Very interesting, our Confirm Centre is quite unique internationally, as we are funded by Science Foundation Ireland for basic manufacturing research, so low TRL, low technology readiness level research, discovery-led research that underpins the next generation of manufacturing key enabling technologies. And that feeds our more applied research program with industry. So you can see those we have in our spider diagram, our applied research program with industry and our more fundamental research program. So very much a uniqueness in the international landscape in manufacturing R&D. Won't get into the key enabling technologies too much, but also what we have is we want to be known for internationally as a digital physical and cyber physical manufacturing systems engineering research center, very much around distributed test beds, so to test bed our technologies and showcase that to industry, and also around the complete digital future factory. So that's our uniqueness on an international stage. Very quickly, just to talk about the Confirm Industry 4 checkup tool based on Fraunhofer technology. So we'll be launching this tool this year, and this is basically a digital checkup for industry. So we will send engineers into industry. We have unique algorithms that basically can derive a roadmap for your digital journey. So if you want to see, do you train the staff to be, to work with cobots first, or do you buy the cobot first and then put the 5G network in second and then train the staff, or do you build a machine first, and all sorts. So there's very many different sort of routes to becoming more digitalized, or digitized. So this is an assessment tool that we're going to be launching in the next couple of weeks. Just to mention that. Confirm really is about the decision making in manufacturing, hence the name Confirm. And really what we think about as cyber physical systems or digital physical systems, we take data from machines, from the humans and the workers in the factory, and the supply chain and the mobility in the factory and supply chain. Take that data, bring it into the digital world, use that data to drive models of the manufacturing or supply chain processes. Those models can be sort of, closed form models, can be algorithms, can be AI, can be sort of any sort of data model you can think about. And then those models are used to make decisions on the process, feed that decision back down to the manufacturing process in the real world, and to make more competitive, make more efficiencies in the manufacturing domain. So that's what the Confirm Research Centre is about. Just to say, our new headquarters has been designed around a research village concept. So we've taken our research program I talked about a few minutes ago, and we've asked the architects to implement that into our new facility. So what does that mean? We have a very much a digital piece, like a cloud server, full immersive 3D room, 5G network, 10 gigabyte internet access, and then we have a physical domain where we have a test bed facility and 70 researchers and management staff. This is a look at the finished product. So this was built the day the university finished. Today the university was closed last April, or was it March, for COVID-19. We have been in there a little bit, in and out. We have industry in there already working away with some robotics research. But we're hoping to get back in here as soon as possible, to our brand new research facility. So an amazing facility. Just to say, within that, I'll very quickly, we have a lecture theatre, as you can see in the bottom right corner here. The next time we hope to have the event in person, we will have you all at this facility, 100-seater venue. We have a full production floor, as you can see here as well. So we have what we call that our test bed space for testing out equipment. We have what the 5G innovation zone, and just to say, it's the first, we believe it's the first 5G private network, internal private network for manufacturing research in Ireland. And just before Christmas, we were running collaborative mobots using that 5G network. So we're already test bedding control of 5G, of mobots over a 5G network. So very interesting development there in our HQ. We have a full immersive 3D cave. Just to say, what is that? You can see some pictures here on the left. That's a full immersive augmented reality experience where you can be in the shared experience with many people, and it's sort of it gets away from the headset idea where you're just there on your own. You can be looking at designs and in 3D or any sort of virtual experience you can think about, really. So that's a full immersive capability. Within that, then we've just launched the i4 experience, which is a public museum, a full 3D public museum that's going to bring people through the Industry 1 back to the steam engine, all the way through time up to current day Industry 4. So we really look forward to opening our doors to that particular activity. This is actually finished. We're ready to go. We just need to get access to the building for this to take care. So that's called the i4 experience, and it will be a public experience for schools and children and anybody who's interested in the fourth or any industrial revolution. Just to say, it's a final slide from me, just to say also, the Confirm Centre is very much around the cyber, or the digital and the physical. So we have a full cloud server in there. We have a full sort of data server and computational power, full 10 gigabyte internet cable. Just to put that in perspective, all of UL is run off a 10 gigabyte cable. We have 10 gigabyte cable for 70 researchers. So really strong internet, 5G network to really drive the digital attributes of our centre. So thank you for your attention, and I look forward to hearing the talks myself, and we'll get back to you at the Q&A later. Thank you very much.
Thanks, Conor, and thanks for that overview. I think we just got word there that the results from the first poll are in, so I might just share those now if that's okay. Brilliant. So the majority of people, 78%, voted for option C, which is of course the most accurate description. There's a few people voting for other options as well. So hopefully after tonight's event, we'll have clarified the definition of Industry 4.0 for you. So thank you. So next up we have our keynote speaker this evening, Dr. Owen Hinchy. So Owen is a postdoctoral researcher in Confirm, and he's also a Science Foundation Ireland Industry Fellow with Analog Devices International. Owen holds the Honours Bachelor Mechanical Engineering degree from UCD and was awarded his PhD in UL in 2016 for his project in collaboration with Lufthansa Technic Turbine in Shannon. After his PhD, Owen went on to work with Depuy Synth in Cork for 2 years, developing advanced manufacturing technologies before returning to UL in 2018 to research digital twin technology at the Confirm Centre. In March 2020, Owen started a 24-month part-time SFI industry fellowship with Analog Devices International, where he's researching digital twin-based safety systems for factories of the future. So I'll hand you over to Owen now, who will give his presentation.
That's brilliant. Thanks, Sean. So I'm delighted and honored to be asked to present here today. So my name is Dr. Owen Hinchy. So I'm a postdoctoral researcher here at the Confirm Smart Manufacturing Centre, but I'm also an SFI industry fellow with Analog Devices. So my presentation today is on digital twins in manufacturing, steps towards digital engineering, the factory of the future. So just an outline of the presentation today. So we're going to talk about just an introduction to Industry 4 and what is it. We're going to talk about digital twin, the future role of the human operator, and then challenges of human-robot collaboration. And then I'm going to talk about some exciting work we're doing with new technology in terms of 3D time of flight. So in terms of the polls, we just have one poll that Maureen's going to share there now in terms of your perception of the role of the operator in the factory of the future. So Maura will pop that up there. So as that pops up, I'm going to keep moving on. So in terms of manufacturing progress then, so we've heard of Industry 4 a lot, but a lot of people don't actually realize what it is. So Industry 4 is the fourth industrial revolution. So the fourth industrial revolution, I suppose, follows the three before it. So the first industrial revolution was mechanized production. Then following that, then we had mass production. And then following that again, we had automation and PLC. So automation and PLC is Industry 3, like what Morris is talking about. And now we're in Industry 4. So Industry 4.0 and smart manufacturing are sort of the same thing, and essentially they're based around cyber physical production systems using key enabling technologies that Connor mentioned. So some of these technologies include the likes of 3D printing, sensor fusion, artificial intelligence, Internet of Things, big data, augmented reality, virtual reality, and so on. So we've heard a lot of these technologies, but I suppose one I want to dive a bit deeper into is digital twin, because digital twin is in my own research area. So I'm often asked, what is a digital twin? Because a lot of people have an idea what it is, but they're not entirely sure. They've heard the name, but they don't know. So one quote here from Forbes is that one quote from Forbes here is quite simply that a digital twin is a virtual model of a process, a product, or a service. Then Deloitte came out and said that a digital twin is a near real-time digital image of a physical object or process which helps optimize business performance. And then just last year, IBM took their stance on it, saying that a digital twin is a virtual representation of a physical object or system across its life cycle. It uses real-time data and other sources to enable learning, reasoning, and dynamically recalibrating for improved decision-making. So that's quite a mouthful. But if we distill that down, we can see that a digital twin has three main attributes. So the first is that it's a digital representation of something physical. The second is that there's a real-time connection. And the third is that it adds value in some form or another. So taking a step back from manufacturing, I just want to talk about a real-world digital twin that a lot of us will be familiar with. So we should all be familiar with this interface here, and this is actually Google Maps, or maybe you're familiar with Apple Maps. Now, Google Maps is essentially a digital representation of something physical because all the lines here on the screen essentially indicate a road network in Ireland. It has a real-time connection because, as you see now, these roads are colored. They're colored green where there's low traffic, they're colored orange where there's some traffic, and red where there's heavy traffic, like on the Childers Road that you can see in the image there, which is typically a traffic black spot. But also, it needs to add value. So does Google Maps add value? Well, yes, it does. Because we can see traffic, we can be redirected around it. So if we're using Google Maps for navigation, Google Maps will give us the quickest route, helping us avoid traffic. And even if we don't use it, those who are using it free up the busy roads for us who aren't using it. So there's value for everyone, not just those who are using it for navigation. So looking at digital twin then from a manufacturing perspective, there's essentially three main streams of research in digital twins. So the first is in product design, where we look at conceptual design into detailed design into virtual verification. Then there's enterprise-based digital twins, and Adam is going to speak about that. He's going to touch on that in the next talk. But that goes right down from your field devices, so your actuators and sensors, up to your PLCs, your SCADA systems, your manufacturing execution systems, all the way up to your enterprise resource planning. But my own research area looks at manufacturing system-based digital twins, and they are digital twins that have three main components: the digital twin of the machine, the digital twin of the product, and the digital twin of the process. So just to delve a little bit deeper on that, this schematic here shows this architecture approach that we're using. So right here, we can see that we've got our machine in the middle, our product on the left, and our process on the right. And we've got our physical and our cyber on the top and the bottom. So for the machine, we have our physical drilling robot that we show here in a photograph. Beneath that, then we've got essentially a digital model that's connected. So that's the machine digital twin. Likewise, we've got our physical product here. Beneath that, we've got a digital model of that, which is our product digital twin. And then for our process, then we've got a physical drilling process shown up here on the top right. And in the bottom right, then we've got a finite element model of our drilling. So that's our process digital twin. But what's the point of digital twins? We hear a lot about them, but what do they do? Well, they offer value in three main areas. So the first is the past, because a product digital twin is actually very good at recording data. So you can record likes of date time, operators, sensor data, process variability. In terms of the present, then, our machine digital twin can enable real-time control. So we can compensate for variability using simulations or artificial intelligence. And then in the future, we can use our digital twins for predictions. So we can do virtual testing of new materials or new processes, and also enables us to do virtual commissioning as well. So I'm going to park digital twin for now, and I'm going to talk about the operator and the role of the operator. So the question is there a place for humans in the world of cyber physical systems and factory of the future? Well, the simple answer for that is yes, there is. So some examples that we see are the likes of an augmented reality or a virtual reality operator. And these are operators that are now enhanced with this new technology, such as augmented reality or virtual reality. But one that's quite close to my own heart is collaborative robot operators. And this is where my own research area is, and I'm going to talk about this a bit more. And then I'm going to talk about the idea of the human cyber physical production system. So I just want to mention it here now, and then I'm going to touch on it later on. So if we take a step back and just look at robots in industry, so typically there's two types of robots. There's the industrial robot and the collaborative robot. So industrial robots, like the one shown here, so this is a photograph of Jameer, which is an industrial robot in Confirm. So these robots are typically very efficient and they have very few errors, resulting in very high quality manufacturing. But they also have very heavy payloads. So for example, the payload in the end of this robot weighs 180 kilograms. So to put that in perspective, it's the size of a decent sized motorbike, and it swings it around like a ragdoll. And because of that, these robots are potentially hazardous to humans. As a result, we need to essentially pin in the robot inside guardings and also safety devices like light curtains and so on. And because of that, then there's actually less flexibility on the manufacturing floor. So if we look at this angle here, what we can see is that although the robot may be operating in the green area, like shown, the orange area here, although we're not using it, because it's enclosed by guardings, we lose that space. So that's wasted space that we can't optimize. We can't turn it into a corridor. We can't use it for storage because the robot needs it in its robot cell, even though we're not using it right now. On the other side of the coin, we've got collaborative robots. And here's just an example of some on the right. So typically collaborative robots, they're speed limited, so they move slower than industrial robots. They're force limited, and often they have a rounded design just to essentially reduce pressure on impact. So according to ISO 10218 part 1, there's 4 types of human-robot collaboration. The first is a safety-rated monitored stop, which means that if you get it within a certain distance of the robot will stop, yet remain energized. There's hand guiding, so that's where you guide the robot, so the robot is powered, and you're moving it using a pendant or a device. There's speed and separation monitoring, which really falls into factory of the future, and I'm going to talk about that in my next slide. And the final one then is power and force limiting. So power and force limiting really are that the robot can impact the human, but the force is limited. So essentially it won't do any serious damage. So in terms of the speed and separation monitoring then, this is the idea of a fenceless robot system. So this is where we see factory of the future, is that we can take down the guarding. So essentially the robot and the operator can share the same space. So instead of there being physical guards, we've got essentially safety rated laser scanners that are guarding the area. And then there's a separation distance between the human and the robot. And as the human approaches the robot, once this distance, once this threshold has been crossed, then the robot will slow down or will stop. And this distance is a function of the speed of the robot, the speed of the operator, and the speed of the response time. Now, one of the technologies we have been working on is on 3D time-of-flight sensing. So 3D time-of-flight is essentially a sensing technology that allows a lot more value in terms of safety sensing for factory of the future. So the way it works is we've got essentially a time-of-flight module here with a laser emitter and a laser receiver. And the laser emitter essentially emits a pulse of laser light, which is modulated, and it reflects off an object like a human, as we see here, and it's then received. And what happens then is, what we can do is we can calculate the distance that the object is away from the module. But we're not just doing that for a line, we're doing that for essentially an image, like a camera image. So like the schematic here, what we can see is there's a person in green, label number 1, they're 0.61 meters close to the camera, whereas there's the person at the back there, labeled 5, which is 8 meters away. And using this technology and by processing this information, what we can do is we can develop safety systems for human-robot collaboration. So Analog Devices, who my fellowship is with, have this latest module that's coming out, which is essentially a megapixel array for 3D time-of-flight. And there's a lot of advantages for this technology over traditional 2D LiDAR, and this includes better field of view, much higher resolution, and also better object classification. So if we look at the schematic there on the right, what we have is we've got our safety zone, but then what we need is an extended safety zone using typical 2D LiDAR, because a human can reach in, their arms can stretch in. So we need to extend that safety zone to make sure that their fingertips won't get in reach of the robot. But with essentially 3D time-of-flight, we get a 3D image, so we can detect overhangs, so we can detect somebody reaching in. And because of that, then we can actually reduce our safety zone, but we can still have a system which is just as safe. So I'm doing my research in the Analog Devices Catalyst Collaboration Centre. So there's a photo of the outside there and the inside here. So this is based in Limerick. It's on the Analog Devices Raheen campus. So this collaboration centre is designed so we can collaborate with different customers. So one collaboration that's currently ongoing is with Johnson & Johnson's Advanced Technology Centre. And we're developing this safety bubble demonstrator. So I have a photograph here on the right. So this yellow box highlights the robot. So this is a Universal Robots UR10. Beneath that then we've put 3 time-of-flight cameras. There's a photo of one up close so you can see it. And then on the right there, what we have is we've got a HMI. And on the HMI, you can see just there on the right, you can see the outline of a person. So that's live 3D image of a person that's standing close to the robot. And we've set up algorithms here that when somebody enters a certain distance of the robot stops. So we've demonstrated this, and it can actually detect a pointing human finger. So we've done trials where we've put our arm at arm's length, pointing our finger out, walk towards this robot, and as soon as the tip of the finger crosses the threshold, the robot stops. So that was quite impressive to see. So I mentioned the human cyber physical production system, and what does that look like? So if we consider we've got this physical twin, we've got our humans and our robots working together. And if we can put all these sensors around the factory floor called ubiquitous sensing, so that's sensing that's everywhere, what we can do is we can feed that into an adaptive control system, which fuels this digital twin, so this digital representation of the manufacturing workspace. So then when, say, a person gets too close to a robot, what we can do is we can send signals to actuators from our adaptive control system and get that robot just to move away. So what we're doing is we're moving the hazard away from the human. So just looking at that a bit deeper in the schematic, the idea is that we could take down the guard. So if we consider this being a manufacturing floor, so we're looking down on a manufacturing floor, and we see all these robots spinning around working. Well, this area I've highlighted in red here, so this is essentially robot zones that have been guarded with fixed guarding. And because there's fixed guarding there, we lose that space. So whether those robots are being used or not, that guarding is there, so we can't use that space. But in the future, what we can do with this technology is we can take down the guards. So what we have here now is just local dynamic safety zones around the robots. And that means we free up a lot more floor space for utilization by the likes of autonomous robots or storage or things like that. But it'd be great to be able to say, right, this is fantastic. I want one of these for my factory. But to be honest, the technology isn't there yet because there are a number of challenges. So one challenge is data generation. So I mentioned we've got these megapixel time-of-flight cameras, and it's all well and good you've got 1 or 2 of them. But when you consider you've got a massive manufacturing floor with a load of these cameras, you've got a huge amount of data. You've got terabytes of data being generated. So that signal needs to be, or that data needs to be processed. And also, if there's an overlap of laser emissions as well, they can confuse sensors. So essentially, we need to do work on that as well. Of course, in terms of the algorithms, then artificial intelligence and safety, they don't go hand in hand at the moment. So safety needs to be very simple, very robust, very reliable. AI is a bit more complex. So getting the two of them to work together is quite tricky. And if AI is used in a safety system, there needs to be essentially a backup in case that AI fails. Control signals is also a very important point. So that's interoperability. So what that means is that different robots communicate with different programming languages. So if you've got a system that wants to move a KUKA robot away, the control to move that KUKA robot, the signals are going to be different than if it's a Fanuc robot or an ABB robot or a universal robot. So essentially a platform needs to be developed to enable that interoperability. And finally, GDPR is also a big challenge. So again, you've got cameras here looking at the manufacturing floor. With cameras, obviously, you could be recording people, and with that, there's GDPR regulation over it. So the question is raised on, should you do edge processing and keep it locally on the device, or do you do cloud processing and so on? So these are questions that need to be, I suppose, thought through and answered before we can offer this as I suppose, a commercial offering. But there's more applications than just safety. So another application is gesture recognition. So with these cameras, you've got a very, very good depth of field, and we can pick out, let's say, hand gestures as well. So for example, in the animation here, a human might come into the robot and want to inspect the part. So they can do a gesture and the robot will move away and they can inspect the part. And then when they've finished their inspection, they can put their hand back down and the robot will go back to doing what it's doing. Another application then could be robot bin picking. So here we have a robot picking random parts out of a bin. If we're looking down onto the bin, if you look at that image there on the top, you can see that it's quite difficult to see, right, what part is actually on top. But with 3D time of flight, because we can get the depth measurement in 3D, we can essentially see what parts are on top. We can colorize them, and we can use that 3D data, those 3D point clouds, combine that with the CAD data to find out what parts are what way they're orientated, and then we can control a robot to make sure they can pick up the part each time. Because something like this is very trivial for a human to pick a part out, but to get a robot to do it, it is quite complex. Here's just a photograph here of a few parts in a bin, and then the bottom right image there shows the 3D time of flight image. So again, the dark blue in this case shows something that's quite close, whereas the cyan and the light green is something that's far away. So again, you can essentially discern these parts based on their height away from the camera or their distance from the camera. And finally, the last application with regard to robots that I want to talk about is in terms of autonomous mobile robots. So autonomous mobile robots are essentially mobile platforms with robot or cobot arms stuck to them. And because they're mobile, we can't put guardings around them because they just look silly, really, and they wouldn't really function that well. So traditionally, autonomous mobile robots use 2D LiDAR. And again, I have the example here of an autonomous mobile robot with essentially a LiDAR beam aimed essentially at ankle height. So it's on the ground. And these are quite reliable to detect objects that are in the way. But one thing they can't do is they can't detect cables or overhangs or so on. Whereas if we actually use 3D time of flight on our autonomous mobile robots, what we can do then is we can actually detect these overhangs. So for example, we can see that this man's arm or this woman's arm is pointing out. So it may catch the robot if the robot was to drive by. So with the technology, we can detect cables and overhangs, so we can get much safer navigation around the manufacturing floor. But also we can do object classification. So we can determine, well, this object in front of me, there's a 98% chance it's a human, or maybe it's just a pallet full of boxes. And based on that decision, then the robot can make a decision. It can decide, well, if it's human, I need to slow down, or I should change direction, or I should turn around and go somewhere else. Whereas if it's only a bunch of pallets, well, then I can drive by them at full speed because there's no hazard there. So just to summarize what we covered in, I suppose, this brief talk is that we gave an overview of digital twin and manufacturing, discussing that concept of machine, the product, and the process. We talked about the human cyber-physical manufacturing system, and then we looked at opportunities for smart sensing with 3D time of flight, looking at dynamic safety zones. We looked at robot gesture control. We looked at bin picking and autonomous mobile robots. So just to finish, I just want to acknowledge Science Foundation Ireland. I want to acknowledge Confirm as well, Analog Devices, and also Johnson & Johnson's Advanced Technology Centre. And I want to leave you with this tweet here. So this tweet was from Elon Musk with regard to the making of the Tesla Model 3 production line. So when Tesla were making the Model 3 production line, they made it highly automated and they had loads of problems with it. So Elon Musk eventually came out and said, yes, excessive automation at Tesla was a mistake. To be precise, by mistake, humans are underrated. So with that, I'd like to just bring up the poll we did the first time round. I'm going to just ask the question again as to see if your perspective has changed in terms of the role of the humans in manufacturing of the future. So thank you very much.
Thanks very much, Owen. That was a really, really interesting presentation. I suppose from a lot of our work in Confirm, we come across this fear that humans are going to be obsolete, I suppose, in the future. So it's great to see that there'll be a place for humans in the factories of the future also. And so I think we might move on to the next speaker while the audience is answering the poll question there, Owen. So I'd like to welcome Adam O'Toole from Novartis. So Adam is an enterprise IT architect based in Novartis Global Service Centre in Dublin. He's responsible for defining the technology strategy within manufacturing and engineering across Novartis global manufacturing sites. Adam has a diverse background across multiple engineering disciplines, such as software, control systems, and manufacturing within the pharmaceutical and medical device sector in Ireland. He's currently the lead architect on a global IT team to bring advanced analytics to Novartis manufacturing sites worldwide. So I'd like to hand you over to Adam now to give us a presentation.
Thank you, Sean, for the introduction. So for those of you not familiar with pharma, you may have wondered what is involved in pharma drug production, or for instance, why drug products are so expensive. And why, for instance, now that we have the COVID-19 vaccine, why can't we just ramp up production and deliver it faster and distribute it around the world? The reality is that pharma production is hugely complicated, but it's also littered with inefficiencies. At Novartis, our ambition is to be the leading focused medicines company powered by data science and digital technologies, utilizing the latest technologies to empower the pharma value chain to deliver drugs at a faster rate, at a higher quality, and ultimately at a cheaper cost to customers and patients around the world. Pharma is behind other industries in terms of technology. Historically, this is due to a strong focus on drug development, availability of drugs over process improvements, and slow adoption of technologies to support this. It's also a highly regulated industry, making changes both difficult and challenging. In pharma production, here are some of today's challenges. There's a significant amount of manual labor, a lot of manual process steps, and low supplier visibility. Production lines are configured to produce drugs in batches, and all of this leads to higher costs of drug products and ultimately production delays. So looking at the entire value chain for pharma drug production, there are, I suppose, many opportunities for technology to impact and do things smarter and better. From sourcing of supplies and materials, through drug research in laboratories, to manufacturing the entire drug process through factories, and also through planning and supply chain and inventory management. But the focus of my presentation today is smart manufacturing. In other words, smart factory, an area in which we've made considerable progress at Novartis. Having worked as a manufacturing engineer in one of my previous roles, my day-to-day responsibilities included attending shop floor production meetings at whiteboards, where production issues were discussed. As a team, we would discuss what had happened impacting production in the previous day. And as an engineer, I would perform root cause investigations, gathering data from multiple different systems in manufacturing, doing data analysis in Excel with a view to determining what had gone wrong that had affected our production line. As an overall manufacturing facility, ultimately we were reactive to issues impacting our production line. And I think this is a familiar story to many working in manufacturing today. So imagine if we could do this better, if we could gather all this data, connect it together in real time, and combine it with the powers of artificial intelligence. Those inefficiencies that I spoke of would disappear. We would no longer be chasing our tails. performing investigations into what had gone wrong, the information and data would tell us what is happening in real time. That's where our vision in 2019 started at Novartis, the vision of a global insight center to deliver smart manufacturing, to digitally enable our manufacturing facilities around the world, removing the need for manual investigations, providing real-time visibility on actual performance versus a target performance, become a single source of truth for manufacturing site performance and KPI reporting. And as Owen referred to in his presentation, ultimately create a site digital twin of the production process, where the physical process becomes a virtual one. And ask, why would we do all this? Why do it? What are the benefits? This is a view to removing transactional efforts, increasing efficiencies in our production plants, and ultimately preventing line failures and stoppages. So how to do it is the question. Smart factory starts with data. The underlying foundation of smart factory is data. And I'm sure many of you have heard the term before that data is the new oil. And that's certainly the case for us at Novartis. When you're trying to digitalize your entire portfolio of manufacturing plants, of which there are over 50 worldwide, certainly data is the foundation and enabler for this. And our vision at Novartis was not just to connect one plant with this, was to connect all our plants together around the world, fueled by data. So the challenge for me as an architect, a technology architect, was to come up with a solution that would not just work for one plant alone, but all of our plants, which had a lot of differences and subtle changes on each factory floor. The high level solution is shown here and consists of some key elements: extracting data from our factory shop floor systems in our manufacturing sites, using the latest edge and IoT technology to extract this data in real time, combining it with the latest cloud-based technologies to deliver a digital production twin of the manufacturing process, a digital twin with advanced analytics, artificial intelligence, and machine learning capabilities. In other words, utilize our previously disconnected data sets in our factories to digitally enable our shop floors and sites from shop floor to top floor enterprise level. This is an example of what we've achieved so far. Here are some examples of displays that you can see now on our production sites, visible on tablets, mobile devices, and digital display screens around the site. On the left here, we have a dashboard at one site showing the top level key performance indicators. What was planned versus how the site is actually performing in terms of quality performance, throughput time, speed of production, and average performance. We also have a breakdown of the performance of the different brands. And on the left here, we can also see on this graphic a breakdown of all of the production stages in pharma, what production stages are on time, depicted in blue, the production stages that are behind schedule, depicted in orange, and the production stages that actually have an issue that needs immediate investigation. All of this empowers production personnel to instantly see a virtual replica of the production plant performance and do immediate investigations. The inefficiencies of gathering this information to piece it together are gone. On the right, we have a timeline view and breakdown of different batches and production stages, where they are versus target. We can see today's current status of today in this vertical line here, and we can respond to issues in real time proactively. All of this reduces the throughput time and proactive responding to issues. And to drill down that piece further, for issues and investigations where something has gone wrong, or to drill down and find out more, we have the ability to drill down to machine level information, looking at the performance of individual machines in the manufacturing process. Here's the performance of one of our production analyzers that we can drill down and see information on. It shows the current performance of this machine in the factory. We can see the production rates in the line on the graph, the time the machine was down in red, the time the machine was idle in yellow, and the time that the machine was producing in green. Ultimately, we get an accurate picture of the overall effectiveness of that machine. This gives live information that we never had before at the touch of a button, and issues in production can easily be diagnosed. And now to the most exciting part of this is that it's all empowered by artificial intelligence. So going back to what I said at the start, imagine we go one step further and not only know what is happening at our production plants, but we get insights into what will happen before it even happens. We then become proactive in our response to issues instead of reactive. Advanced artificial intelligence and machine learning spot trends in the data sets and predict to a high degree of accuracy when batches will ship and where the likely issues will be. So that image of me as an engineer trying to piece together these pieces of information on the production floor becomes a distant memory. This is far more advanced than humans, providing insights on our processes that we as humans never thought possible. We as people are the limitation when it comes to advanced data analytics. This is what we're doing at Novartis, and this is what I believe will be a game changer for us and also the pharma industry in general. And to my last slide, this is only the tip of the iceberg. In the area I focused on today, smart manufacturing, at Novartis, we now have real-time visibility of our site performances and the ability to predict manufacturing issues ahead of time. We have ongoing developments and planned projects in the other areas of the value chain, such as smarter sourcing, smarter laboratories, making our supply chains smarter and more visible using data. And all of this is building up to a full site and network level digital twin. This is and will continue to lead to faster delivery of drugs at a cheaper cost and at a higher quality for patients and customers around the world. I thank you for the opportunity to share this with you today, and I look forward to hearing any questions. Thank you.
Thanks very much, Adam, for that great presentation. I think it was really great to see how the impact that digitalization is having at Novartis, like both in terms of, like you said, that it's belonging to be proactive rather than reactive, but also it trickles right down to the patient, as you said, in terms of the quality of the drugs you're producing and the efficiency of your plants. So thanks very much for that. So our next speakers are from ABB. So I'd like to welcome Alexander Grabish and Paul Mimna, who are going to give a case study of how digitalization has made an impact on the ABB building in Bergamo, Italy. So welcome, Paul and Alexander. Sorry.
Thanks. Thank you indeed. Thank you very much. Good evening, everybody. And just a quick thank you for taking the time out to attend this evening's webinar, which is jointly presented by my colleague Alexander Grabish and myself, Paul Mimna. During the course of the presentation, we will look at a real life case study, which is the ABB building in Bergamo, Italy, which is a commercial office building. Our aim at the outset was to enable cost savings through energy and asset management by the digitalization and cloud connectivity of circuit breakers and devices in the MV/LV electrical distribution network. We also had to allow for the integration of genset, UPS for critical loads, integration of renewables, and the load management of EV charging. And furthermore, we wanted to achieve this in a very time efficient and cost effective manner in comparison to traditional methods. So look, just a brief description of our roles within ABB. You might need to go back one slide there, Alexander, thanks very much. And we'll share our contact details at the end. I'm the digital solutions lead for ABB in Ireland, and Alexander represents the ABB Global Product Group as an application specialist. So really to set the scene, and as we all know, the spread of connectivity is driving digitalization as the Internet of Things brings together devices and people to help businesses become more competitive. A fundamental aspect of this is that technology is making it easier to collect useful data and to use it for analysis. And connectivity-based solutions increase awareness of resources and process behaviors. So now I think it's a good point to hand over to my colleague Alexander to walk us through how we achieve this in our case study. Over to you, Alexander.
Thank you very much, Paul, for the introduction. Thank you everybody for joining this presentation. So really the digitalization is changing the way how we produce, consume, and also distribute the electric energy. Today we will have a deeper look in the electric distribution. So mostly this is impacting the metering and monitoring part of the electric infrastructures. Looking in the past, usually we had only one meter, which was there mostly for the billing purposes. Today, the things are already changing. So we have more and more metering points in the electric installation, and mostly in order to answer the most complex requirements today, which are the improvement of the energy efficiency, as well as the improvement on the sustainability. Following those trends and looking at the devices available on the market, we may expect that even in the near future, we will have many connected devices within the electric infrastructure, all the way from medium voltage down to low voltage, even down to the loads. And all those devices are going to produce a huge amount of data. I heard many, my previous speakers also speaking about data is a key enabler of new technologies. And actually, to turn this data into valuable information, we need to make use of the artificial intelligence, cloud computing, machine learning, and so on. So today we are going to show you how we improve the performance of our ABB building, which is based in Bergamo in Italy. It's being supplied by the 2 transformers. It also has the PV system on the rooftop, as well as the emergency generators for the critical loads, together with the EV charging stations in the underground floors for the parking area. So what was the scope of work for us? It was actually to create the full electric distribution for this building. Of course, providing the full selectivity between different protection zones. But then to answer the market requirements, as an example, from this year, every new building in European Union needs to be a zero energy emission building. So we have provided the full supervision system for the whole electric infrastructure together with the asset management. Then further improvements for the maintenance on the building itself, as well as we have seamlessly integrated the renewable energy sources, the EV chargers, the gensets, as well as the installation of the UPSs for the critical loads, such as, for example, elevators, emergency lighting. So what was the project outcome? Actually, thanks to this advanced supervision system we installed for this building, we are able to save 70% of the total cost of ownership compared to the traditional supervision system. We also reduced the project time from 3 weeks, which is required for the traditional supervision systems. We actually offer a supervision system which doesn't require any programming at all. Also, the commissioning part is being improved. From 1 week of commissioning for, again, traditional supervision system, we offer only 1 day commissioning. Thanks to the cloud connectivity, artificial intelligence, and I'll show you in a minute how does it work, we are able to save up to 36% on the maintenance cost. Then our solution improves also the value of the facility, as we are compliant with the LEED certifications, contributing to 3 out of 9 LEED categories, which refer to the electric infrastructure actually. Then to ISC 6364/8/3 standard, as well as the ISO 50001 requirements. Those again refer to the electric distribution of the buildings and infrastructure. Thanks to monitoring of the installation, we allow 7% improvement in the energy efficiency, as well as 8% of the electricity bill reduction. I'll show you in a minute. And then we were able to integrate again seamlessly the EV chargers with no impact to the electric infrastructure, again thanks to the energy manager. So let me share with you more details how our system works. Actually, it's based on smart devices and smart components that you already need for your electric infrastructure. our protection devices, such as circuit breakers, molded case air circuit breakers, transfer switching devices, UPSs, all have the embedded metering capabilities. So they are by their own able to collect all the data from the electric infrastructure, such as, for example, class 1 accuracy measurement of the power and energy, but even some environmental data, such as temperature, humidity. Then, thanks to several communication protocols, we can connect to the local monitoring system, or just by using a simple gateway, we can push all this information to our ABB Ability Energy and Asset Management cloud-based platform, which was realized together with Microsoft, and only in 10 minutes start to monitor the whole electric infrastructure and perform some advanced functionalities. So let me show you an example what we can do thanks to the cloud connectivity, thanks to artificial intelligence and predictive algorithms. As I mentioned, our devices, we take here the example of circuit breaker, perform a lot of measurements, number of operations, average current, but also some environmental data such as humidity, vibration, temperature, and so on. Now, all this data is being pushed to the cloud, where in the cloud, actually, we perform this complex algorithm, which is based on our knowledge and on our tradition on the electric infrastructure. And then we turn this data into a simple and user-friendly information. When the next maintenance on your device is needed, and what is the health status of your device. So I mentioned that we are able to reduce the electricity bill by 8%, and this is thanks to the power controller functionality, again embedded on our devices, so no additional devices needed for your installation. They take input for other smart devices in the electric installation connected to the loads and also to the renewable energy sources. They take the input by the user based on what are the requirements from the utility, and then perform, again defined by user, switching on and off loads depending on their priority and depending on the availability of the energy from the renewable energy sources as well as from the utility. I just wanted to give you a hint what we are able to do thanks to the digitalization and thanks to our smart devices and connectivity. So to get more information, please go to our websites or reach us out directly, Paul and myself, on our emails. So thank you very much for your attention. I leave the word back to you, Sean. Thanks.
Thanks very much, everyone.
Thanks very much, Paul and Alexander, for that really interesting presentation. It was I suppose looking at it from another perspective of how digitalization can be used to improve efficiency, as you said, and even reduce costs of electricity bills. So that's really great. Thank you so much. And just to the audience, I'd just like to remind you that the Q&A is still open. So we will be moving to Q&A after the next presenter. So just to remind you that to post your questions if you have any. So thanks again to Paul and Alexander for your presentation there. So our next speaker, excuse me, so our next speaker is Brian Mulligan. So Brian qualified as an engineer from UCD in 1978 and originally worked in mathematical modeling and simulation and the application of information technology and engineering. He's currently the head of online learning innovation in the Centre for Online Learning at the Institute of Technology, Sligo, where he has worked as a lecturer and learning technology developer since 1984. Brian has been a leader in online distance learning in Ireland, initiating the country's largest provider, IT Sligo Online, in 2002, and has contributed significantly to the growth of e-learning in Ireland since 1999 as a founding member of the Irish Learning Technology Association. So welcome, Brian, and I'll hand it over to you there now.
Okay, hi everyone. I hope you can hear me okay and see my screen. I think I have the wrong screen up here at the moment. I'll just get the full slide. Okay, 10 minutes to talk about Higher Education 4.0. Now, Higher Education 4.0 is a project that we've just been funded for, and it's not Industry 4.0, I'll admit that, but it is inspired by Industry 4.0. And given the skills that you require in Industry 4.0 and the constant change in those skills, we would maintain that it is vital part of what you need. Now, I'd just like to start by an example of what might be described as digital transformation of education. And this is a work-based degree that we launched last September. And in a way, it's a new way of thinking about how kids would get their degrees, because it's a combination of apprenticeship, of our degrees we've been doing for years on campus, and what we've been doing in online distance learning. The students come from Leaving Cert, they go into a job near them. They spend 3 days working online, and they're working in the workplace, and they're paid for that. They spend 2 days studying online, so they have an income. They can live at home. It's more affordable. But the most important thing for us is that this will build a better engineer, because they perform better in the workplace and they'll perform better in their studies. This is an example I want you to think about it as digital transformation in education. Now, I want to talk about digitizing of continuing education, because I just want to take some lessons from this, because this is what I've been doing for the past 20 years. In the 90s, I was watching this in the 90s. You could develop this interactive multimedia. It was very expensive to develop, and lucky for me, I didn't have the money to work in it. Some people used to describe it as click to continue. It used to come up in CD-ROMs or big silver discs. It was very expensive to produce, and a lot of people considered it quite boring. In a way, in the noughties, things flipped almost the other way, because suddenly you had the YouTube generation coming in. This is the people creating their own amateur creations of content, and suddenly people finding this amateur creations really, really useful. This is sort of user-generated content, and as well, live online, what we're doing now actually, live online began to emerge as being affordable. Live conferencing, web-based conferencing was affordable, so we could do live online education. In 2002, we started our online distance learning in manufacturing with a degree in quality management, a top-up degree in quality management. And all it really was live online evening classes. It wasn't that big a deal. Another big event was in 2012, what they called the Year of the MOOC in education, which was massive open online courses. It was really free online courses, but of course they had no accreditation, and that's why a lot of people discounted them. In 2020, just to say where we are at this point, we reached 4,500 online learners last September. In actual fact, we're about 4,800 now. Now, given that we've 3,500 campus learners, that's a phenomenal growth. But to be honest with you, it was like pushing an open door. Growth was 20% per year, and then when COVID hit, it went up to 25% last year. But everybody in the country, all the evening classes in the country went online. So this is where I come to a question for you. What will happen afterwards? Is there no way back from this? Well, I would say, unfortunately, I expect that things will probably go back to normal on campus. And to be fair, on evening classes or continuing education, we'll say, I think it will continue online, because the people who want that continuing education won't tolerate going back to classes. But this is one thing I want to draw attention to here. In a way, this was not really digitalization. It's just digitalization. It's just taking the models we've always had and putting it online. So giving the same old boring classes online as we've been given in the classroom. We need to move beyond this. There's a lot happening out there that suggests that we can move beyond this. An awful lot of things basically in business models for education and in teaching models. And I'm going to have quite a messy slide here where I'm going to go through a lot of things. So here goes. Massive open online courses, I've mentioned. There's a company in Galway, Allison, that does this as well, free online courses. Low-cost online university people. LinkedIn Learning, you can get your courses very cheaply. Unbundling in higher education is a concept where some people develop the content, some people deliver it, and maybe even other people give credits for it. The MOOCs, the massive open online courses, have now started giving credit, assessing their students and giving credentials or giving certificates, as it were. Georgia Tech's online master's and degree program was a phenomenal development. A computer science master's degree for $7,000 in the US was a phenomenally cheap program. They have about 5,000 people on this program, probably more at this stage, and it will probably do a lot of damage to universities and their master's programs in computer science. When it comes to it, are degrees the way things are going to be in the future? Degrees have a lot of value to employers because they're sort of good proof of the nature of a candidate. But if we have alternative methods of doing that, alternative ways of showing what people know, if it's digital, it'll be much easier to prove. It'll be much easier to verify what people courses they've taken, what are the value of these courses, what's in these courses. And of course, if we use technology like blockchain, that will improve its reliability again. What about different ways of learning? Now people can direct their own learning, decide what they want to learn. This can be used on campus where we can go, and in regular classes where we can say, I'm not going to talk to you about stuff in the classroom. You can do that before class. And when we come to class, we want to be doing interesting applications of what you've been learning. What about students who can learn stuff on their own and then get together and help each other understand it, peer learning? What about not defining what people learn, allowing them to choose, driving learning by what their interests are or by what they need? Free range learning is a concept there as well. Now, a lot of this, if we're going to, in higher education, continue to give degrees, we're going to have to be able to give people credit for the learning they find on their own. So recognition of prior learning will become much more important in the future. An example might be the European MOOC Consortium, where a group of universities around Europe have decided to recognize each other's free online learning or low-cost online learning. What about authentic learning? The degree apprenticeships, a lot of people may have heard about this, and this has started even in Ireland. We saw it first probably in the UK, noticed it first in the UK. We've got a degree apprenticeship in insurance practice, but do there have to be apprenticeships? Do they have to be through that system? Can we just not design the work-based degrees where kids go into the workplace and learn as they go along, as I described in that first slide? We know that they don't necessarily have to come to college. What we can do with simulations now is really fantastic. So do they really need to even come to college to go to labs? Well, also because we're in the mechatronics business, we know that we can build experiments or learning exercises for them and allow them remote access. We've done that in Sligo. Also, and a lot of students will sit and go to college. They want the learning experience, but do they really need to sit in class? Can they not just do projects and take all their learning of content off to the side, as it were, self-study? And of course, we need to keep an eye on if they're doing this. But there are AI systems, adaptive learning systems emerging that will keep an eye on students' behavior and do it. So if I were to say digital transformation is about not just moving from traditional to the digitization of traditional, but it's moving further than that to new models, low-cost models where artificial intelligence monitors and adapts the programs, moving away from degrees to other credentials, measuring competencies rather than did you get 40% in the exam, and work-based and project-based. Which brings me to our project that's just been recently funded by the Human Capital Initiative. And this is from the Connacht Ulster Alliance, the 3 colleges that are working towards become a technological university: Galway Mayo, Letterkenny, and IT Sligo. This project is called Higher Education 4.4. And our tagline for this is enabling agile responsiveness from higher education, making higher education responsive to the needs of employers. So this will have an external focus to what employers need and an internal focus for us producing what's needed. So we will talk to employers. This will be part of our operation. We'll liaise with employers, find out what the skills needs are. We'll talk to individuals with employment to see how do they see their careers, what skills they already have, what they need to get, and then we need to provide them with courses. So that was the easy bit on the left. Now we have the hard bit, which is internal in the colleges, because we're not really known for our agility. A part of that is our academic processes for approval of new programs and getting programs. But so we need to work on having leaner approval processes for new programs. We also need to be able to produce them quicker. So we need rapid, lean development systems for creating new programs and getting them available to employers and individuals in the workforce as soon as possible. This project also includes us developing new models of learning. And one of these would be low-cost self-study models. In other words, MOOC-type studying, where people can study at their own pace, and it doesn't cost a lot. And of course, we want them to get credit for that there's some sort of assessment. Work-based degrees, we think, will be an important new model in the future, as I described in the first slide, and project-based degrees, because we know a lot of kids are going to want to go to college. They don't want to go into, it's amazing the number that probably do want to go straight into the workforce, but a lot will want to go to college. And so the ones that do want to college, we want the learning to be more authentic. And it can be now because of the technology that's available. They can spend their days doing projects. They can learn the stuff, the mechanics, the electrical principles, all those things they can learn at online in a self-study mode that's heavily monitored. The trouble with these two modes is that we need a lot of help. And that's why I wanted to talk today, is because we really need to talk to industry about this, because we need their help, both to find projects for students, but also to find placements on work-based degrees and that sort of thing. But we think it's worth it. We think that you will get better engineers through new models of learning. And these new models of learning are possible through the use of technology. Thank you very much.
Thanks very much, Brian. Really interesting perspective there. Again, I suppose coming from a different point of view, again, to the other two presentations, looking at it from the education point of view. But I think obviously that was the purpose of tonight's event, I suppose, to show the impact of digitalization right across the board, from industry to education. So thanks very much for your presentation. So I think we're going to move to Q&A now. So I'm going to pass over to my colleague, Patrick Reedy, who's been looking at your questions in the background. So Patrick, over to you for the Q&A, please.
Thanks so much, Sean. Look, thanks to all the speakers for their really interesting presentations. And again, guys, look, there's been plenty of questions coming through on the Q&A, and the speakers have all been beavering away answering behind the scenes as well. So thanks so much. And given we're maybe under time pressure, I'm going to try and get to at least one question for all the panelists. So Owen, maybe to kick off with yourself,
yeah.
In terms of your own area of research, if you look at, the human in the loop, as you've mentioned, have you looked at wearables, rather than looking at the 3D time of flight sensors in the work that you're doing?
Yeah, so I suppose there's two avenues that you can go down. One is wearables, where you can track the movement of humans with like a smartwatch or an RFID device or something like that. And the other option is 3D time of flight, where essentially you don't need to give that person a wearable. So I suppose there's been some research out there that kind of alludes to that. If you're giving someone a wearable, they feel a lot more tracked, because they're like, oh, they're tracking me with this wearable. And like, if we think, even forget about tracking the person, if you look at the safety system in general, if that wearable is on your left arm or your right arm, and you stretch your arms out both sides, that's probably what, a 1.5 meter span that you could be in a robot cell, so that will really extend out that safety zone. Whereas using 3D time of flight, you get very accurate measurements, so you're talking in the region of millimeters. So like that's why for the safety application, that's why we're considering 3D time of flight rather than wearables. Now that's not to say that wearables can't go hand in hand with 3D time of flight for sensor fusion and improve safety. So
brilliant. Thanks so much for that answer. And just moving on to yourself, Adam. Look, again, really interesting presentation, and very apt given the topic tonight. I suppose, for me, how did you scale across multiple sites globally? It looks to get this working in one site is fantastic, but how do you scale across everything?
Yeah, it's a particular challenge we had with 50 plus sites across the world. But for me, as I mentioned, data availability, starting with data. So across our sites, we had different source systems, different levels of digital maturity across the various sites. In some cases, we had no data even existing at all. We had some paper records. So really, we had to put the foundation in first, creating the data to give us this information. Once we have that foundation, that digital foundation, it's easy to scale to other sites. So yeah, to me, start to scale, we have to have data, and it's easy to scale to the sites that have it already. And for the sites that we can't scale it to, we have to put in that data as the foundation first.
Yeah, it was interesting. Yeah, the concept of data silos. I think everybody everybody on the call tonight can understand that, and and how you have to have that as a standard and try and scale from there. I might move on to Paul and Alexander next, and we can maybe look at some other questions into the wider group afterwards. So Paul and Alexander, look, definitely again, we're constantly looking at the circular economy and energy use. In terms of your own presentation, what's the difference between the monitoring system that you guys have implemented on your office in Italy versus SCADA systems or building management systems that are already available? Can you give us maybe a little more insight into that?
Yeah, maybe I can take, and then Paul, if you want, you feel
Yes.
free to integrate. Yeah, thanks. Thanks very much, Pat, for the question. Really, a really great question for that. So I wouldn't really directly compare it to the SCADA system and to the BMS system. This is really a system which is mostly focusing on the monitoring of the installation. So it doesn't control the components and infrastructure itself. So the reason for this is actually a cybersecurity. Maybe we didn't have a chance to mention this, but this is one of the biggest concerns when it comes to the cloud monitoring, cloud connectivity. You don't want that someone access your plant and then control your devices. So for this reason, we do not allow any control from the cloud. And then we have realized this system which can work really well in parallel with the existing BMS or SCADA system, which is there more for the control. Or it can work as a standalone, maybe for the facilities which require only monitoring, maybe without control. And then it gives you a further value thanks to these cloud algorithms, thanks to the predictive maintenance feature we mentioned. And it's very different from let's say, traditional BMSs and SCADA system as it's ready to go. It doesn't require a programming, and again, it allows you improvements on your electric infrastructure. Hope that answers the question. Yeah, maybe Paul, if you want to.
Yeah, I'd just like to say that again, and I think I might have mentioned this, that I think a fundamental aspect of this platform is that the technology is making it easier to collect useful data and to use it for analysis. And the analytics on the cloud do that for you, which is a key difference. It's not just monitoring, but it's using the data and empowering you then to make decisions, which is a key difference. Okay, both in terms of energy management and the management and the condition of the assets. Okay, and the assets are circuit breakers, electrical devices, instrumentation, etc. Even motors and variable speed drives would come under that as well, all on the one platform. And that's what makes this so powerful.
Yeah, no, really interesting. Again, echoing Adam's point about accessing or having availability of access to data, is a fundamental start, to be able to conduct that sort of work in the cloud. I might move on to Brian, and then we'll open up the floor to other questions. Just Brian, in terms of your own presentation, obviously, look, you're looking at digital transformation in education. If you look at, the Irish higher education system at the moment, like in terms of, it's been pretty standardized for quite a while, and if we don't continue to innovate, are we at risk, of international players coming into the field and also disrupting what would be known as traditional education?
Yeah, that's a really interesting bit of future gazing there, because the internet, we can see it in even just online shopping and everything like that, where I can buy stuff from Germany rather than go down to a local shop. Could the same happen in education as well? And theoretically, it certainly could. There's no reason, and people are. We get people from Japan, South Africa, enrolling in our online courses, and people in Ireland can enroll in courses from the US and elsewhere. Now, there is certainly people have had a preference for enrolling in colleges close to them. This has been shown, and that they're more familiar with. But that's been all other things being equal. A lot of it now, the reason people enroll internationally is because there's just not enough courses available in their own region. That will change. There is also what's coming is low-cost online education, like that master's in computer science for $7,000 from Georgia Tech. Georgia Tech's a pretty good university, a lot of people might do that from Ireland. So international competition is I would say it's certainly possible. It's highly and quite probable, we'll say, and it's certainly a thing that Irish higher education needs to be watching out for. Of course, there is all the opposite. There is the opposite. There's an opportunity. We have some great researchers, great colleges. We should be thinking about getting there first and getting our education out into the world, and particularly in engineering, because there isn't a lot of engineering. This is one thing that surprised us in Sligo, was we were just sort of doing what came natural to us to a certain extent, and then found out that we were one of the few people teaching automation technology in the world online, and we were getting inquiries from all over the world. So there's great opportunities for us here as well.
Yeah, no, I think certainly, and as part of Confirm, I think, from the very outset and led by Conor, we've really looked at the internationalization aspect of Confirm as well, because we're not only competing with on an Irish landscape, we're competing on an international landscape with, as you mentioned, those colleges that are at a global level. So certainly I think it's a valuable lesson for everybody. I might bring Conor in on some of the more general questions here, Conor, and there's some that I might direct towards yourself. There's one interesting one here. I think it's something that we come across quite a bit. It goes, how do you see industry that is in operation 20 plus years adapting to the protocols of Industry 4.0? Will the cost of implementation outweigh the benefits, in terms of that sort of legacy companies?
Yeah, it's a very good question. Thanks, Pat. And so I suppose it really depends on on the business value. So the thing to do is not to rush in and tech out, sort of in our experience, is to tech out your plant just for the sake of it, So maybe there's two points I want to make. So I have a colleague of mine in Siemens in Germany who make the gas turbine blades, and Siemens is a leading global company, as we all know. And they decided about 2 years ago, this guy's in senior management in this particular company anyway, and they said, well, okay, what are we going to do? We want to be Industry 4 compliant. What are we going to do? So they all sat around at the table and the board of management, whatever, and decided, okay, let's put everything on the internet. So they decided in the whole factory that every machine was going to, phase one, just get everything on the internet first of all. So that was interesting. So some of the projects that we're doing in Confirm, just on the legacy equipment, and it's a very important question for Ireland, because we have billions of euros of sort of equipment in production plants in medtech and pharma and so on that isn't going to be replaced. But sort of legacy equipment, we do, in the Confirm, we're developing with some industrial partners some autonomous sensing, so you can retrofit machines with taking the data with a wireless, maybe autonomous sensor, low powered sensors that can be plugged on in locations where you need to take certain types of data to do the analytics and to make it more digitalized. So to answer the question, I think the business value, the business need needs to be there first, I would say, before the technology is rolled out. And then there's ways to do it. Sometimes it's a research question. You might need to go back, and work with people like Confirm and so on to test stuff out before you buy, if you like, and then, or else you can make the investment with consultants or people who deploy these technologies. But yeah, so I think but definitely I think that what I'm hearing anyway is the business value needs to be there first, and really that's the important piece. I think you're on mute there, Pat.
Yeah, I'm mute. Sorry, apologies. I think, guys, just in the interest of time, we might wrap up the Q&A there. And I know that we've had quite a few questions, and we can maybe deal with them offline. We can get back to the guys that have asked the questions and reply over the next day or so. But look, thanks so much for asking some really interesting questions, and thanks to the panel for answering also.
Thanks, Pat.
Thanks very much.
So sorry, I'm interrupting the panel there, excuse me. Just to close off this evening's event, I'd like to welcome Barry Lowe. So Barry is the engineering manager at Lufthansa Technik in Shannon, and he's representing the Thomond region of Engineers Ireland this evening. So thanks, Barry.
Good evening, everyone. Hope you all enjoyed this evening's event. And as Morris pointed out, we've had a number of Industry 4 and smart manufacturing events over the last couple of years, but most of them have focused on the technologies and not really on the application of the technologies. And I think what really excited me about tonight's presentations was we had a chance to see the application of some of the technologies we'd have heard about in the past. I'd like to thank Morris, our president, for coming down to come online to open our event. And I was surprised. I hadn't realized Mars had such a history on the evolution of robotics and digitalization. So maybe Mars, you'll give us a keynote speech at one of our future events. Connor and his team, I'd like to thank you. Obviously, it was great to have you host the event, and it was nice to get an update on the collaboration that's taken place between industry and Confirm. So thank you for that. But I suppose a special thanks to our presenters, and we had Owen, Adam, Alex, Paul, and Brian, and I know what goes into preparing these presentations. So big thank you to you guys for putting the work in and actually sharing the information that you shared with us tonight. We really appreciate that. So we're going to share the slides from the presentations tonight, so we'll forward those to you. We're also going to include a short survey because we'd really like to get your input and inform us in terms of what your preferences are for future events, and we'd really appreciate it if you take a few minutes to do that. Finally, I suppose I'd like to put an invite out there to anybody that's interested in getting more involved with Engineers Ireland. We are always keen to welcome new members. We have over 25,000 members in Ireland, but there's still a lot of engineers out there who we'd appeal to join Engineers Ireland. It's a strong network, and we have a lot of activity in the Thomond region. Our next event is on the 4th of March, and it's operational excellence, achieving reliability through production and maintenance partnership. And that's a presentation going to be given by Ron Moore, who's managing partner with the RM Group. And if you're interested in that, you'll find more details on the Engineers Ireland website. And finally, I'd like to thank all of you who participated tonight. It was great to have such a turnout for the event, and I hope you all enjoyed it. And I look forward to having you join some of our future events. Thank you very much. Good night.